he changed his mind. Y'all got some good guesses today. Good. All right. So today we're kind of switching gears. We're moving into more like bash specific. So we're going to be talking about the bash shell. We will actually be writing our first script today, but don't get too excited. It's basically kind of the default hello world version that's out there. And then if hopefully we'll get some time. I know some people had some questions about that that assignment 1 out there, so I'd like to kind of review some of that and see if y'all have any questions. So we'll see how the time goes here. All right, so you all know I love little cartoons. So we got 2 people sitting in front of what looks to be maybe a nuclear bomb, and then one of the person yells for Rob, use Linux. Guy says, come quick. So Rob gets over and he reads the screen and it says, to disarm the bomb, simply enter a valid tar command on your first try. No Googling, you got 10 seconds. And then we move on, and then Rob's staring at the screen, and then they're like, Rob? And then, I'm sorry, guys. So apparently Rob couldn't remember his tar command. So the moral of the story is don't be Rob right here. Make sure you actually know your tar commands. They'll definitely be on your exam. Now, why in the world you would disarm a nuclear bomb with a tar command, I have no idea, but you know, moving on. All right, so talking about the bash shell. So it is based off of the Bourne shell right here. And then let's see, what was it on here? There it is. And then we've also got the dash shell, again, based off of that Bourne shell. It's just a much smaller version than the bash shell that we will actually be using right here. And then there's some other versions, the Corn shell. It is also a derivative from the Bourne shell. I think on the Mac, what are y'all using? ZSH. I'm not actually too familiar with ZSH and kind of what it's a derivative of there. But not really important to know any of this stuff. It's just showing you there are many, many, many shells out there. And what you got?
Is Corn shell just Unix specific? Is that the difference, main difference, or?
Unix specific, like it only works on a Unix machine. Is that what you're saying? I believe it works on just any distribution. I mean, you can install these. Like we could install the Corn shell on our machine and use it. Just like the Macs could actually install a bash shell and use it on there.
It's just like different syntax.
Yeah, there are different flavors of it. You know, they're configured differently. You know, the prompts may look different. It's kind of just lots of people wrote different ones. You go out there and you pick the flavor that you want. You're not locked into it. It's just all the distributions kind of, okay, I'm going to pick this flavor of the shell that we like. But you're not locked into them at all. And then, of course, all of these, the one thing they kind of have in common is they're trying to, you know, stick to that POSIX standard. So that way, at least you can work in all of them and there's some type of similarity as far as how they're structured. All right, so we're going to talk about the different types of shells. And this is stuff you're really not even going to hardly notice, but there actually is different types that are out there. The first shell is going to be our login shell. So login shell is just a shell that's going to prompt you for a username and password when you log into it. So there's different types. You know, we got system, virtual, it could be remote through SSH. So lots of different methods here, but note that login shells are interactive right there. So that's one of the key things. You can interact with them. This is an example. This is not something, again, it can be different. Of course, this is specific to bash right here. Now there's going to be lots of similarities to it, and the fact that, you know, we're all going to kind of have those Etsy profiles right here. But when we kind of go over here to we have the bash underscore login, where you kind of see those bash names, that's where you're going to get a lot of variation between the flavors. And even between one bash and one system and another bash, you may or may not have all of these. So I can't tell you like this is going to be the concrete method. This is just understand the general flow of things. So when we log into the system, it's going to trigger /bin/bash for those that are using bash. It's going to go out there and hit this Etsy profile. There's going to be some code in that. There's also going to be this Etsy profile.d, and this is going to probably point there and be like, okay, if there's any file, you can see that wildcard that ends in .sh that is inside this profile.d directory, and kind of notice that this is a common thing Linux will do. you have a file called profile. And then if there's a directory that does the same thing, you'll have profile.d, just kind of so you can easily distinguish if you don't have color codes and all that stuff. You could just run a simple ls and know which ones are directories, which ones aren't. So if there's any scripts in here, then it's going to execute those scripts as well. And then at some point, probably in here, it's going to wind up kind of handing this over to your local directory right here. And so you could have a hidden file right there called bash_profile. It will have some code. It runs it. It could have a bash login. I don't see that as much right there. It could have a .profile, but all of them, as far as bash goes, that I have seen always has this .bashrc, and that's where you're going to find kind of the bulk of a lot of your personalized, just for you, settings that are in there. And we'll take a look at that one today. And then right here, it could even go back and point to a bash version. I don't think ours does right here. So just a general flow, and understand that basically this right here gets hit first, and then these settings take over. So once these settings are in place right here, if you actually modify this right here, it could overwrite some of those settings, but it's not overriding it for everybody. It's just overriding it for you, allowing you to customize. So, you know, these personal settings has priority over these right here. Now, all of this right here, it's important to understand, this is global settings. So it applies to all users. While this is, you know, all this green right here, that applies only to you. So if you edit this, nobody else is affected.
Settings you can change or customizations you can do.
You can change your UMass. That's one thing. If you want your files to kind of default to a specific permission set other than what everybody else has, you could change that. We'll actually, it's going to be a cart before the horse thing. We'll touch with on aliases today, when you kind of create your own custom command. So if you have a command that you want, or if you have a command that's kind of already on the system, but you don't like the default options. In other words, it's kind of plain, but you would like some options. You could create your own custom like word that will reference that command and give the options that you like to that command. So you kind of create your own custom command. We'll even later on create functions. We could declare functions where that would be a set of commands. You could create one word that would have multiple commands, and it would all execute them. And we'll do that as a homework assignment in here. So there's lots of different things. If you wanted to create a bashrc.d where you don't configure that, maybe you just have a script that you keep all the time with all of your custom settings, then you could actually write your own code to pull the information from that file, where then you don't have to sit there and edit that file. You just have one that you put on all of your systems. And then you write a simple, you know, one line of code right here, and then you've configured your system the way you want everywhere. So, I mean, it's up to you. I mean, there's lots of stuff you can do. That's the beauty of Linux, and also kind of the daunting side of Linux. So again, global, not global. That's very, very important for y'all to remember. All right, interactive non-login shell. It's the same thing. It just doesn't prompt you for a username and password. And, you know, we still got, you know, the stuff being hit right here. But understand, like, this right here, because you're already logged into your system, it's not hitting kind of the global settings. So you're already going to have that. Those settings are going to be passed down to the non-login shell. Then we have non-interactive shells. And this right here, understand that every single time like if I ran the date command on Linux, it is actually spawning a subshell. That would be a non-interactive. I can't interact with it. It happens in the blink of the eye. We don't even see it. And it ran that command in a subshell. The subshell sent it back to its parents, the results, and then we see the results. So that's a perfect example of a non-interactive shell every time we run a command. All right, now environment variables. We'll hit these a little bit further again, kind of, but environment variables are, we'll put up here, global variables. So This means the same thing. If you see the word environment, it means global. And when we talk about global, that means the parent is able to pass that information to a child. So when we run a script, that script will be able to take the global variables that are currently in our shell and then send it to the parent. Let's see. I don't think we've hit anything. I can get a good example on that, but I'll also make note that it doesn't work the opposite direction. A parent cannot pass information. Sorry, a child cannot pass information to the parent, but a parent obviously can pass down information to their child. So if you declare something global in a subshell and then you close that subshell, the original shell will know nothing about that. And we'll see some examples later on of that happening. Now, how you'll see that is they're variables. It's just a name equals value pair. We'll take a look at some of them on our system. Also kind of make note the no space in between that. The equal sign has to touch that. And we think we'll maybe next lecture, we talk about creating like our own custom variables. And we'll talk more about how ticky those variables are. And of course, right there is kind of an overview of the inheritance. And then here is where we can actually see some of those. Go back here. So if we did print env, so this is printing my environment variables, so we can kind of see those a bit larger right here. So you can see, like if I did shell right here, you can see that it equals to bin bash. So if I went down here and I said echo $shell, and then you can see that's the value of that variable. That's all I'm doing. Also note that global variables in the system, it's common practice that your global variables be uppercase. Now, could you create a global variable and it be lowercase? Yeah, but it's kind of the best practice is local variables, lowercase, global variables, uppercase. We'll revisit path right here. I just didn't use that as the example right there, but y'all can do that on your own if you want. But it's just another variable and we'll touch on that variable. Okay, startup files, again, that can be your .bash profile or your bash RC file. So this is where you can kind of customize your shell in there. And here I give an example. And now I know we haven't touched on this right here whatsoever, but we will touch and talk more about aliases. So let's actually show how we can do this. So if I said history, that's a command. So that just keeps track of all of the commands I've ever typed, in the shell right here. And that is a keyword. It's not across the system. If I was to spawn another shell and type in it would have its own history set. But this is the default shell that I log into every time. So it keeps that history over time there. Now, if I wanted to create an alias, so I could say alias, and I could say H here. One of the things you'd want to do first is I make sure H is not a command right here. So if I hit H, you can see it didn't find anything. So I'm good to use that. So I could say H equals, and I could say history. And let's actually pipe it and do a tell. So that way we don't get the whole history right here. I can hit enter. And now if I hit H, run that, you can see now I created my own little custom command right here using aliases. Now, when it comes to startup files, if I was to, we'll just open Vim, and since I'm in this directory, well, here, we'll do this, prove it's there. So if we do AS or ls-al, we can look in our home directories. That's where it's going to be located. We have that .bash RC file. So I'm going to go ahead and open that file up. And then I'm going to go ahead and just copy this one right here. And since it's already there, I'll tell you what I'm going to do. I'll just create H2. That shouldn't be anything. Okay, so again, I'm going to go film.bash RC, open that up. Here is the bash RC file right here. So you can see there's the history size. So it'll tell how many commands, you're going to remember over time. There's just lots of stuff in here. Of course, a lot of it's directories. It's looking for files. This is bash script. We're not there yet, so we're not going to worry too much. I'm going to use Shift-G and get all the way to the bottom right here. And if we take a look up here, you can actually see we're already using aliases. So you'll see me kind of shortcutting LL. So that is an alias to the ls command with these options right there. LA is a capital A option, and, you know, so we're already using some of them. So what I'm going to do is hit O here. It's going to put me in insert, but give me a new line right here. And I'm just going to say custom alias. And then now I'm going to backspace that and then paste in my alias that I did. And then just so we can see that it's not the current one that I ran, I'm going to call this one H2. You can create anything you want. So I have that. It's in there now. What do I need to do from here? How can I save this? Escape, colon, it would be WQ. We need to write first and then quit right there. So now I have that. Now watch this. If I hit H2, hit enter. Ooh, that's weird, isn't it? Didn't I just create that?
Like reboot or restart the show.
That's really, that's great. Why? Why would it do that?
The computer science Bible restart. It works.
What would you have over there?
Because the bash RC file is only read at the beginning.
Perfect, perfect. So it doesn't know anything. I edited this file, but the file hasn't been read by the system, so it's not been loaded into memory, because that's what happens. It reads all these scripts, loads it into the memory, so it's there for us in the shell. Now, that is a way, perfect way to do it. But if you're in a production environment, probably not the best way. You don't want to have to restart your machine, but it would work perfectly. What we have is what we call a source. So we can source the .bash RC file. I think I have more information here on it. So the source command, once you do that and you specify a file, what that does, it forces it to read it and then just load the contents in memory. So we can kind of refresh that. There are two different ways to do it. There's the fully spelled out source command, or the really confusing and headache for everybody is a period. I told you, we're going to see the period has lots of different meanings. If you connect it at the beginning of a file name, the file name is hidden. It also represents the present working directory that you're in. And now here, if we do period space and then a file name, it means source. Was there a question?
Yeah. I tried to vim that .bash RC and I got something. Like I didn't get like it's completely different. They have like numbers on the left, it was all blue.
Okay, that right there is my custom Vim file that I did in the last one, all the color codes, the line numbers. You kind of did that, or no, it's your current homework assignment due tonight. You create your own custom Vim file. So that's why mine looks different than yours. It's because it's heavily configured, even beyond what you do in yours. So that's why the looks are different right there. But as long as the contents, like yours is all blue in there, as long as you have the contents, you're still good. It's just not going to have same color scheme. Okay, so now if I want this to work, we could, again, we could type source, or just to show you, I'm going to just do the period so you can kind of see the confusing version. And then if I did the bash RC, hit enter. So now you can see I'm using the dot as source, and then I'm doing a dot before the name because it is a hidden file right there. And then now if I call H2, you can see it's available to me. But if I was to open up a new shell, and when I do that, this is a whole new instance right there. So H2 is going to be available to me, even though I sourced it over here, but this shell has no idea that actually took place. It's a completely different shell. So that would be kind of the reboot method you're talking about. And of course, that's another beneficial thing of virtual terminals. We can just open up tab and kind of force that like it was a reboot. But again, if you're on a production machine, you may not have all of those options right there. So the source command works great. All right. We do not have to know all of these at this point, but I always like to point out moments where you're going to be confused because you're going to see it in the future, and I want you to anticipate that you're going to see it. So we kind of have these symbols, parentheses, the brackets, the $ here that we've been working with. Brackets by itself right here represents a subshell. That you'll kind of understand that a little bit later on when we're programming. And then we got one, the same thing preceded with the $. That is command substitution. That we'll talk about that on the next slide. But pay attention right here. What do y'all think those are? Quotation marks? Backtick marks. It's hard to know, isn't it? This is depreciated. And that is the reason why, because if you ask a group of people, some people are saying quotation marks, some people are going to say backticks. These are backticks right here. And that used to be the only way to do command substitution. So don't do this. It's confusing, depreciated. They say not to do it, but you need to know it because if you start looking at older code on the internet, you'll see this in lots of places, and you need to understand that's what's actually taking place. Then we had this arithmetic evaluation. LET came first, and honestly, a lot of people still use LET. It's not like a depreciated thing. The difference that you would do like LET, and then you would do your math after it, while here your math would go in the middle of it. So it's kind of up to you on which one you want to use. Arithmetic expansion, again, we will cover these two later in more depth. Then we have a test command. So this is when we're testing a condition. And this is basically the updated version of the test command. And then we'll see there's actually 3 different versions of this right here, but we'll talk about that later. All right, so the one thing you do need to remember is command substitution. This will be coming up, and we don't have a homework assignment this lecture, but the next one, there'll be a homework assignment with it. So command substitution, this allows us to run a command or kind of differentiate that, hey, this is a command and I want to run it. Well, you're probably asking, well, why do we need it? Well, let's get in the shell and we can play around with that. So if I was to say PWD, you can see I ran the command, it got the information back. Now, if I was to say echo PWD, what do y'all think I would get? PWD. Okay, so there's a problem, right? This is where command substitution comes in. So now I can come in here and say, okay, nope, PWD, close it all up and hit enter. Now I've differentiated that, and now it knows to run it as a command. So anytime, and this is important, so echo, the actual argument it is expecting is a string. So same as if I was doing the grep command there. So it expects a string after that. So if I wanted to perform a grep on in my script, where I'm searching for whoever's running that script, I need to grep for their username for some reason. Well, I don't know their username. So if I want to do that, then I would need to grep and use command substitution and use maybe a variable like, let's see, I think user would get it. So right there, that would be perfect. I could use that as an option, and it would then grep for that person's username there.
So you don't have to put the quotation marks and you don't do the parentheses.
Okay, you'll catch me doing that. It's called laziness. We will talk, it is, yes, I should be doing double quotes around it. We will talk later on because it actually changes. It's perfect that you did ask that. No quotes will do something different than single quotes and double quotes. All 3 of those actually have different meanings. I know when I can use it and when I can't, and I just kind of do it the lazy way. But yes, I should be putting double quotes around everything. The best practice is always do double quotes. 99% of the time, you're going to get exactly what you want if you do double quotes. Single quotes, not so much. But again, getting ahead of ourselves on that. But great question. So this example right here, ls command. So then I'm piping that to grep. So I'm thinking in this example, somewhere, who am I is actually a command that's going to get me that username. So there's some file in here that has my username in it, and I'm just, sending it to, or ls. So I'm getting the contents of all of the files, piping it to grep, and then searching for that name. All right, we've seen redirection operators. So here I've kind of showed you those defaults a little bit. Now this isn't everything, but the 2 new things in here, this shouldn't be important for anything we're doing. But if your system is set up, and we'll show you how to modify those settings, but some systems are set up where it's not going to overwrite an existing file by default. So if that's the case, you put a pipe after that and it'll force it to do that. All of our systems should be set up to override. It'll do exactly what we said. So in a production environment, this may be more common. because you don't want to accidentally overwrite a file that's very, very important. So you would want to configure your system not to do that. And then, so that's the new one. And then these two are the new one. So the ampersand before them, all that says is do both, standard out, standard error. And of course, then we have, you know, overwrite and append right there. So if you put an ampersand before it, then it's just saying, hey, do standard out, which is 1, and standard error, which is 2. All right, moving on to shell script. So again, I'm going to say this, and it's still probably going to be confusing because I do it every semester. Anything that you do on the command line, you can do in a script. Everything we've seen, we can just put it right in a script and it's going to work perfectly there. Okay, now kind of right here is talking about permissions. So when we write a script, again, we talked about the contents are important right here. So if we wrote a text file, and we could even name it .txt at the end, .sh is the most common extension, or it should be the extension used for writing scripts. But if I end it with .txt and I wrote code in it that was bash, and then I actually did the file command to see what type of file it is. Is it a text document or is it a script? It's going to come back and let me know, hey, this is a bash script. So it is a script, but in order for it to be a proper script that is executable, we need to actually make it executable. So again, if it's in this class, everything should be ran by the user. So it would be like U plus X, you know, the user needs to have the executable permissions. Yeah, you could put it on group, you could put it on other if you wanted to, but not really required to. Anything you send to me, I become the owner of. So as long as the user has executable permissions, you're good to go. And you are graded on that. If you send me a script and it doesn't have execute permissions, then I'm going to be knocking off points because you just created extra work on me and it's not an executable script. I asked you to send me an executable script. Okay, so here is our first script if y'all want to follow along. Let's see here. It's this one. It's just a comment and then a shell script. All right, we can do that. Okay, so all we got to do is we use Vim right here. And then I think I called this something like first script. I don't know. And then I want to end it with a .sh right there. So that's going to be kind of the common way. You can name it whatever you want right there, but put that .sh extension on it. That way, everybody that gets this file knows that it's going to be a script. So once you got that, hit enter. Now we're opening Vim. Yours may look different than mine. So I'm going to hit I for insert here. And then we need to actually tell what is going to run this script. It's actually called a shebang. So to do that, you would do pound. Pound is actually a comment, and then we do the exclamation after it. And then we're going to write bin/bash. So that is the location of the bash shell on my system right there. Then let's write a comment, and I'm just going to put this is a comment. And then I am going to go ahead, and yours won't do the pound sign automatically like mine. I'm going to go ahead and write echo, and then we'll just do the famous hello world. So again, comment, and then the actual code right there. Once you have that, what do I need to do?
I quit.
What do I need to hit on the keyboard?
Escape.
Escape, perfect. Somebody tell me something different than :Q. Shift ZZ. All right, now if I do ls, that script should be there. Now let's do ls-al. All right, am I good to go? Is my script ready? What you got? Executable. All right, how do I do that? Anybody else? We got the first part down. Nobody else? Yep. You, well, not equals. What is equal going to do if I did U equals X? Yeah, it would overwrite, right? I would lose my read and write permission. So we could do +X and then just give it our argument. All right, now if I do this, we should kind of have a little color code difference. It's actually a little green file. Again, not all systems are going to do that right there. And the important thing that it has the X on it. Sorry, what?
Can you go back up real quick?
Oh, you want to see the command?
Yeah.
All right, yeah, chmod u plus X.
Okay.
All right, now, how do we run it? Okay, we do that with /. Again, another dot. This time it has a special meaning because we put a slash there and then we're going to connect that to the file name. So if I was to do this, then we've got a valid run right here. So // first script, hit enter, and then it's just going to run the code that I did. Also note, if I was to go up here and we'll just say oops, that wasn't minus X, and then we'll do an AS-AL, oops, LS-AL. So now you can see I've got it turned off where that doesn't happen. If you just want to quickly run something, you can actually call a subshell with the bash command and then give it the file and it'll run it as well. But again, that's a quick workaround method that is going to be counted off on you if you don't put, because a lot of times when I'm grading, I've got scripts that are going to call all of this stuff. And so my scripts are going to just have // and then I'll feed in your script as the argument to run it. Especially when we start getting into multiple arguments, I'll already have the arguments programmed. What?
Is there any kind of script that could see if the computer that you're running on it had bash, and if it didn't, it would use it like form?
Actually, if you go through some of your startup files, it will check to see if the version is bash in it. But yeah, I mean, you can write your own code to check which shell that is there. There's a quick check right there. The $shell actually has it. So then you could write a condition that after if $shell is equal to bin bash, then do X. And then if it's not, then you could do a check for ZSH. And if it is, then do this. Okay, so we kind of saw our first script right there. It's going to be a little bit, really, it's going to be after our first exam before we start really getting into scripts right there. So don't get too excited, but it's kind of a fun detour. Now we've got one last topic to keep up, and that is jobs. And jobs is one of those things that it's not so important anymore. Used to, it was extremely important because now we got virtual terminals. And even with SSH, you could have multiple SSH connections because most of the time you're going to be working in a virtual terminal, and then you could just SSH into the same server from all those virtual terminals that you had open right there. But what jobs allows us to do is see what kind of put something in the foreground or the background. Because I kind of told you everything we've been doing right now is in the foreground. So we're going to see a way that we can send stuff to the background and still work in that same shell. And this is good to understand because it's kind of one of those fundamental things. And also I will show you when it comes to the screw up, if you do Shift ZZZ or Shift ZZ, that's how you should do it. If you accidentally do Control Z, then this right here will help you get that job back. And we'll show an example of it here. So important concept to know, but again, not so much that you're going to use it in the future right here. So jobs, it just kind of keeps track of all of the jobs that we have initiated in the current shell that we're in. That's kind of important because it doesn't track all the processes that are going on. It tracks what we are doing just in that current shell, and that's it. So here's the command, jobs. That'll list everything. If we run that, it'll list everything that we are currently doing. So if you run it right now and you're not actively doing anything, it's not going to have anything whatsoever. Should come back blank. Now we have some commands that work with jobs right here, and that is foreground. So if we have something that's sitting in the background that we can't work with, we can use FG and it will actually pull whatever is the most recent job that went into the background. So they're kind of numbered. So if you just recently put something in the background and you ran FG, it's going to default to that last one and it'll pull it to the foreground. Now, if we have something working in the foreground, or actually, no, if we suspend something with Control Z, that'll suspend the job. and then it's in a status, what is called a stopped status, and it's not running, but it's sitting in the background doing nothing. If we give it the BG, so background, then it actually runs it in the background instead of being suspended in the background. Now process, that again, a process, it's any command. So if we run a command, kind of using these methods, if we ran something, we would then have to suspend it, send it to the background. And then if we want it to run, we then need to issue the BG command so it runs in the background. We can skip that if we know we want this to be in the background from the beginning. We can just give whatever command and then a space. And this right here should not be on there. I'll have to delete that. Then you would just put the ampersand, and that tells it, don't go to the foreground, just immediately run in the background. And then this is just saying you can use this with both of them. So foreground or background. And then you reference the actual job ID. We'll see that in a minute. So if you had 7 jobs in the background and the 7th one is the newest one, and you wanted to then use the very first program you put in the background, you would just do % and the number 1, and then that would reference that job. So then you could say, okay, send that to the foreground or send it to the background. All right. Let's just do a quick job so we can actually see how this works. Okay, so again, jobs should be nothing there. Now I'm going to use something very, very simple to start, and that's going to be a sleep timer, and I'm just going to give it 1,000. So now you can see my system is sleeping right now, and I can't do anything. You know, if I was to sit here and type echo, it's just, it's ignoring because the foreground is being taken up by this sleep timer right here. So my system's worthless. So what I could do is I need to actually suspend this. So I could do Control Z. So it's stopped right there. So now if I did jobs, again, it's just going to give me that same thing. Here's the ID that's there. The plus sign means it's the newest job. It's the most recent one. And of course, here's our status, and here's what it's doing. Now, if I want to send this to the, or make it so it's not stopped but running, I could simply do BG. Now, again, we'll do jobs. You can see it's running now. And then you can see it appends that ampersand right there. So again, we'll just do sleep again, and we'll do 2,000 so we can just tell the difference. And then Control C, I'm gonna suspend it. Oh no, I killed it, sorry. Control Z, I want to stop it. So jobs, you can see running. Here's the newest one. That's the previous one. But again, we have our job IDs. So let's actually do another sleep timer of 3,000. And then Control Z, send it to the background. So now I'm not going to do the 3,000 one because that would be simple. I'm going to actually reference this one, and I can't just use BG to do that. I would then need to do %sign and then reference its job ID. And now if we do jobs, you can see that it stopped. And then since this is still my newest one, I could hit BG and it would pick that one up. And then we have our jobs running right there. And then, so if I wanted to actually pull one to the foreground, if it's the newest one, I could just do FG. Now you can see the sleep timer is now running. I can sleep it again. We can do jobs. If I wanted to run or bring this one to the foreground, I could do FG and then %1. Now our sleep 1,000 is running. And again, I'll just stop that right there. All right. So that's kind of the simple version of this, but we can muddy it up some in this new example here. Okay, so I'll do this ping one first. So if we wanted to do ping and I wanted to ping Google, then I can go in here and just say pinggoogle.com. If you're used to using ping on Windows, it will do what, like I think a default 5 pings and then quit. This one runs forever. If you want to actually stop it and get the results, you can Control C it, and then you can see we have our nice results right there. Now, let's say that I don't want this in my foreground. I want it to actually be saved to a file because I'm just running a test, and later I want to see the results of those tests. Well, then I could redirect it, and we'll just redirect it to ping.log here, and then I'm going to hit enter. Okay. That's, you know, again, what's wrong right here?
running in the foreground.
Running in the foreground, even though it doesn't really look like it because we don't have the standard out that's taking, that's because it's being redirected right here. So if I want to send it to the background, we could do Control Z. So now you can see it stopped. We can do our jobs command and we can see that it's in the list now. So I want to send it to the background. So I could do BG. And since it's the newest one, it's now running the background. You know, I now have my terminal back. We do LS, you can see we have the file. I can show you a little trick right here using the tel command. This is how you do log files if you want to actively monitor them. If you do -F, it'll send standard out every time that file is updated. So here's just the newest entries being populated at the bottom right there. So I'm gonna Control C that and kill it. And so now, again, we can do jobs right here. There it is. Now, when I'm done with this, what do y'all think I need to do? Like, I'm tired of I've got the results that I want. I need to close it down. So how would I close the ping for Google there?
To Control C.
Okay, how do I get into it?
Foreground.
Foreground, perfect. So bring it to the foreground. Actually, no. I need to, I guess something changed on me. So let me Control C that one. Let's see what jobs. Let's see. We'll just use the 4 there. So if I did FG and then we'll do %4. So now I have it there, and then you said I can Control C it. Sure enough, I can Control C, and then we can validate that that closed down correctly by using the tel command. And here we can see we had 0 packet loss. Everything was good there. All right. Now I want to show you something that is very, very weird the first time that you run into it here. And that is, let's say I'm going to do ping www.google.com here, and then I'm going to send it to the background. I just want to send it immediately there. And so it's out of my way. Did I do it? Not the exact results that I wanted, right? So here's the fun part is, let's just say I did jobs. You can see there was job here. The S went there. If I did JOBS, hit enter, it still works. Why is that?
I guess it's running in the background, but while it's doing that, it's just sending the output to standard out.
Perfect.
So it's not really taking up your terminal.
Yes, that is a good answer. So what is the default action of ping? What is it going to do? Yeah, it's going to send to standard out, right? So I sent the program to the background, but it's still doing its default job, sending to the foreground right here, it's the standard out. So my shell is not tied up, but it's just being constantly bombarded by, you know, the information there. So again, if I know this, and we can do jobs right here, we can see that it sleeps timer is actually the 1. So we'll have to do 4 again. So if I said foreground and what was it, %, was it 4? Okay. All right. So now let's see what happens if I was to try to type something. Actually, hang on, maybe I didn't do that fast enough. So I did a foreground %4. There we go. It just was too slow. So now you can see that it's actually happening in the foreground and it's taking up space and it's ignoring all of my actual input because it's in the foreground now. So now I can close it down right there. So I just wanted to point out that the sleep timer worked perfectly without anything else because it has no standard out that's happening. But if you choose a program that has standard out, then that's going to interrupt your screen right there. So you would have to then redirect that input somewhere else so it's not interrupting your screen.
So I noticed that the ping working window is still in sleep mode. Does that indicate that background is like one shell with multiple places for programs to run?
It sends it to a sub shell. Yeah, so it's running in its own little shell in the background, a non-interactive shell. I mean, and realize that that's happening every time. Like I told you, every time we run a command, it's actually spawned a sub shell. We just don't see it happening. Okay, now, this is one of the reasons why I wanted to show you this. 37. Let's do this real quick. If I said Vim and then we'll, let's see, make it easier. Okay, directory, just there. CDN there. Now I'll just delete that. All right, so I'm going to do Vim here, and then we'll just create this test file.txt. I'm going to hit enter. I'm going to go in here and just, this is some text. And now right here, I'm going to go ahead and hit escape. And then a common problem that people do, they get used to using Control C, and then instead of doing Shift ZZ, they hit Control ZZ, but understand the extra Z is just, you know, it's extra. It's really Control Z that's doing it. And then you see what happened right here. And then this is a moment of lots of confusion, but we can see jobs. That's actually what's taking place. But now if I go in here and I say Vim, and then I try to do test, I can't tab. Actually, if I do LS here, file doesn't exist. So if I do Vim and just try to spell it all out and then open it up, I get this weird thing right here. And it's basically saying, okay, hey, there's this swap file. So the swap file is, you are not actually editing that file, the test file. The test file doesn't exist until you actually save it. What it's doing is it creates this temporary file. It always starts with .swp, but if you get multiple versions of it, and I don't know the theme of what they do, but it changes the little 3 characters at the end to something different right there. And then it has all the information. One of the things is, one, it can't find test file right there. So that's a hint. If it does find it, it will tell you which one is actually newer than the other one. But in this case, I'm just going to do Q and quit. So if I do ls-al, then you can see it's actually there, right there. So don't panic. You didn't lose all the work that you did on your script. Now, if I don't close the shell down, I have the jobs right here. So note that if I was to spawn a new subshell, and then we'll CD into that delete me directory right here, and we'll show that the file is there. But in the new shell, jobs, it's your current shell. The jobs only works in that current shell. So this one knows nothing. So if you reboot your machine, you close your shell, whatever, you've lost this jobs thing right here. But if you have the jobs, then all I got to do is do FG. Bring it to the foreground. That's no problem right there. Now I can kind of save it here. Now that I've used Shift ZZ to save, if I do LS, that file is there, but it overwrote here. Now, pay attention to this. If we do test file again, and I go in here and just will write new line, and then I escape, I Control Z right here. So now I've kind of got 2 different things right here. So we have the swap and that test file. So if I try to open Vim again right here, you can see that I've got 2 different versions, even though I have that other one. And now what we will do, before I show you how to, a different way of recovering it. Okay, make sure I've still got both of the versions. Okay, so I have both of the versions. So what I'm going to do is close this one down. Again, if I do jobs, we don't have anything. But if I go in here, we have those 2 versions. So if I do Vim test file, it's still going to look in here and be like, oh, there's a different version. And it can see right here that here's the date of the different versions. If I just want to recover it, you can see down here, I can use R right here to recover that, and then hit continue. And then here's my new line right there. And then now I'm going to save it. And you think that that would be the end of it. Jobs will take care of it. But if we do AS-AL, you can see the file still exists. So even though they're both the same file now, if I open it back up, you can see that it's still going to give us this, but it'll say the current file is newer than the swap file. And then it's saying, okay, what do you want to do with this swap file? I could go in and manually delete it, or I could just use the D command here and then delete it. And then if I save it and now I open it, it opens fine. If we go back in here and do AS, see, it's gone. I know, clear as mud a little bit. It takes a little bit of practice getting used to it there, but that's kind of how you handle it. But again, if you just do it real fast on accident, then foreground's your best. I mean, it's simple. But I can't tell you how many scripts that I get with hidden files, and it'll be like 3 different versions of your scripts in there. And I then know like, oh, okay, they control Z'd it, and then they didn't know how to recover it. And then they rewrote the whole entire thing. I kind of have like all the versions of your homework in that file. All right, let's see. 42. We get out at what, 12:05 in here? Okay, real quick, I don't test over this anymore. The directory, this is kind of old stuff. So what it allows you to do is if you are like working way over here in your directory, then you'll have a file that's like 10 sub-levels deep over here, and you're having to go back and forth to them. What you can do is pop them on a stack right here, and I'll just let y'all read this, but right here, if I push demo onto the stack while I'm in literature, then I'm going to have demo on there, and I can simply use this push D command to switch between demo and literature. And then if it gets beyond, if it goes 3, then these are numbered 0, 1, and 2. And then I could just give it an argument of like +2. And then since 0, 1, 2, whatever this is, it would then CD into that directory. So it's kind of the old way, but do y'all want to do that, or would you rather open a virtual terminal with multiple tabs and just tab in between them? That's so much simpler. One thing I do like to point out what this directory command, so that's DIRS. So you can see it's always there. It's just whatever your current directory is. But if I was to CD into, let's say, /etc/profile.d, so I'm there and I want to CD quickly back to it, you can do CD --, and then check that out. I'm just going back and forth, and then it's doing the default thing from that stack of printing the actual directory that you're in as well. So that is something that I do use. I find that very useful because I often am switching between 2 directories, and they may not be, even if they're above. I mean, it's really less typing to do there. All right. Let's see. Your homework. Module 3. Oh, we're in module 4. Nope, it's not. That's the homework currently. Need to go back one more. Assign 1. There it is. Okay, all of you did really, really well with the permissions. There was a couple, like I said, it always happens. If it's I don't think anybody actually got mixed up on the magic number that I can recall, but the symbolic versus octal, some of you did get confused on that, and you tried to do like an octal in the symbolic or vice versa. So, the symbolic needs to be like the actual letters, while the octal is numbers. Let's see. That everybody did really well on this one. For the most part, people did good. I'll talk more in general about some of these. This is the one that everybody got kind of hit on that I wanted to explain. So again, you're doing the sticky bit. So y'all did that correct. Most of you did like 1755, but it's this little key right here, preserve the existing permission. So if we take a look, RWX, that's 421, so it's 7. We got R-XS, so that right there is 5 because you got the 4 and the 1. But remember, the S is the set user ID, and so that is 2. So you're going to have the 2 out in front. So it's going to be 2755 is the existing permissions. You're adding the sticky bit, so you would add that to the set group ID there, which is already 2. Sticky bit's 1, so then you get 3755. So that's where it got y'all on that. Now, I know a lot of y'all are probably upset with me on my grading right here. All of you, you're computer scientists, you're, what's the engineering? I don't know, my brain just went, or cybersecurity. Software engineering, that's what it is. I was trying to get computer in with it. The details matter. And while I went back and I gave you partial credit on there, I think I took off 2 points for like some of the misspelled stuff. If you did not get the permission stuff right on the fill in the blank, you know, you lost full credit because that's the most important part on there. So it was these right here. Some of you misspelled this file right here. Some of you forgot to put it all together. So understand when I'm asking for the command has to work. Like PWD doesn't have any arguments for it. So you were putting in the full command when you did that. But in order to change the permission of this file, I can't just do chmod u+s. That's not going to do anything. The system is going to balk at you and be like, I don't know what you want me to do. So I did count off on you for that. And I know that's very, very ticky, but I did want you to feel that a little bit now. And because when we get to the exams, that's going to be very, very important. There is very, very little actual writing on this one. Matter of fact, the second exam is actually all multiple choice. I would say probably about 85% to 90% somewhere is multiple choice on the first exam as well. But anyway, it does not work. I'm kind of big on that. Anything you do as far as a command goes, I should be able to copy and paste that thing into the machine and it should be able to work. And especially on this one, y'all could have simply created this all yourself and then done it and then copied and pasted those in there. So, because it was open book, it was open everything, y'all had that capability. And y'all see I'm really big on that on your final exam because your final exam is a take-home open book. So you can grade everything yourself in there. And I tell y'all that, and then somebody still makes a 30 or 40 on that thing because they thought they knew it all and they blew through it real fast and then forgot simple things. Any questions on this? What you got? Ooh, good question. I think I've got my chart right here. So looks like we're chapter 4 today. Chapter 5 is going to take probably 2 lectures. So February 13th, we're looking at an exam 1 review. We have a review day in here for that exam. And then so February 18th, that's going to be your first exam for this class. All right. I told y'all there would be kind of pop quizzes in this class right here. So this is going to be your first one. Let me open it up real fast. So y'all need to get out your computers, log into them. We're in what, module 4, quiz 1, make that available. And test options. Oops, I'm giving the answers away. That's nice. Options. Y'all should be able to open it. You don't need Respondus or anything like that, but it is closed book, 10-minute timer, but it's 5 questions. That will take you just a few minutes. Once you are through with that, you are good to go.
It's not working.
It's not working.
That's not. Password.
Oh, that's an old password. I didn't actually paste the password in. Man. There you go. That password should work.